Hello, my name is Mark Roberts, and this is my junior design project that I created. So I made a robot that would search out for an object and then retrieve that object and bring it back to its initial location. So here we have the final product robot. As you can see, it's very beautiful. It is made up of an Arduino Uno, a breadboard. In the very front, we have a proximity sensor. On the sides, you can see there are wheels, and attached to the wheels are these servo motors. Um, this is all connected on the breadboard. And yeah. Oh, there's also a piece of tape that acts as the um retrieval method. So how does this how does this work? Basically, you plug it into a mobile power source. Um, and the wheels, that will cause it to start searching out for a object. Um, there's a couple different modes. Um, it has a normal just search mode where it just goes 1 second at a time, goes forward, looks for anything through its proximity sensor. And if it doesn't see anything, it just keeps repeating that. It goes 10 paces because that's about the length of my room. That's something I could adjust if I knew I was in a bigger setting. Um, and then from there, it turns in it turns right 2 times just so it can start searching back. As you can see, there's only one proximity sensor, so it is like an accordion kind of search if you were to map it out to a bigger place. Um, yeah, that's really all. And then when it finds an object, it starts through the proximity sensor. I have it set so anything 9 centimeters away, which is about this many centimeters. Um, Anything that's that short distance away, it starts taking half steps. So only like half a second, and that'll propel it forward. And then once it gets within 6 to 5 centimeters, it'll just start lunging. And that's when it'll attach itself to the front using the piece of tape. And then after that, it's set just go straight back using the calculated path finding. So let me just show you the code. If I can pull that up, share screen. All right. So this is the Arduino code that is used. As you can see, it is about 455 lines deep. That is terrible coding, just so you know. A lot of it is repeat code. I was not going for clean. I wasn't going for efficient. I was going for the job needs to get done. So we have our 4 servo motors. Those are all of our wheels, 2 on each side. These two correspond to one side, and these two correspond to others. Then you have our trackers. This I variable is actually left over from when I redid the code, so that's actually completely irrelevant. But paces, that tells you how far like lengthwise it goes. Turns, how many times did it turn around? I use that to determine like how far widthwise it goes. Attached is the variable just for me to use if it's attached or not to the car. Um, I need to use that so it can trigger the robot to go back. As this is an autonomous thing and I can't tell it when to go, it has to know itself. Um, this integer distance, that is what the proximity sensor is outputting to. And as you can see, there's a few libraries up here with servos and This is the name of the proximity sensor. This makes a new instance, this which allows us to use the proximity sensor. This sets up all of the this sets up the proximity sensor right here, and this sets up the four servos that we have. And then this is our loop. So this automatically gets looped over and over and over and over. Which means, unfortunately, technically, this doesn't have an, oh, you might not be able to see that, but that the robot doesn't have a off switch. I just set it for when it's done, 20 seconds go by, and then it starts going again. But by that time, you should be able to get the robot and shut it off. It's as simple as hitting the off switch, which I put into the schematic. So these functions here, as you'll see throughout my code, these completely shut off the motors. The servos that I got are continuous servo motors, so they never stop spinning. Once you turn them on, you got to turn them off, or else they're not going to stop. Yeah, and servo attach is how you attach like a specific servo to one of the inputs in the Arduino Uno. This right here is the function that tells you to go straight. As you can see, the servo right is another one. The 0 and 180 is telling it which direction it is going. So it doesn't really matter if these are clockwise or counterclockwise. All that matters is this means all four of my wheels are going in the same direction. That's just how my code's set up. This keeps track of how many paces. There's a paces plus plus down at the end of this function. And this is just making sure that there's nothing. This right here is making sure that there's nothing within 11 centimeters, because that's, if you read the report, that's the proximity sensor. It just defaults to 11. So I have to make sure it's anything 11 and above, even though it gives me a really short range, but it's whatever. This is the function I use to send data to the variable, which gets read. Well, this is a lot of copy and paste, but if this was shorter, then this would make sure this doesn't activate again. Paces plus plus. This is the small steps like I was telling you about before. It's a lot of repeat code. This is my turning functions. So whenever it exceeds 10 paces, the length of my room, it turns around and starts going the other way. At the end of this function, as you can see, there's just a few small things here which just allow it to not stay on the same path. Because if it just turned right, it would stay on the same line, theoretically. Yeah, and at the end, paces is reset, because paces is, it doesn't matter if it gets reset or not. If we know the turns, then we'll be able to figure out how to get back. This is my return function. So whenever attached is back or activated, amount of paces that we have to go. If it's on same line, then it won't activate. If it's not, it didn't matter that it was reset before. This won't activate, because all that would need to have been activated is the turned, and how many times do you turn. If you turn once, you just tell it to go straight. It gets told to go straight. If that's emphasized through here, no. If that's emphasized through this one down here, this one's just telling it to go straight. While this one would be telling it to, specifically, these are turning. These are the turning functions, which way to turn, but then this one down here is telling it to go straight back to where it is. And that works. You might have also noticed in here the delay is multiplied by how many turns there are. It's also present in this one up here by paces. That way you can make the robot keep going for however many paces it caused. These are the exact values that they were up in the previous functions. So that's how that is. So it can go exactly the amount. Um, Other than that, I mean, here are the YouTube demonstrations if you'd like to see how it works. I'm not going to give a live demo, but if you would like to watch the YouTube videos, you can do that. Um, Other than that, yeah, that's this final presentation. Thank you very much for your time, and hail to Pitt.